Alright, welcome back to Everything in Swift, and let's solve the Leetcode problem. So the Leetcode problem is the number of ways to divide the long corridors. So along a long library corridor, there is a line of seats and decorative plant. So we are given a zero in the string corridor of length n consisting of the letter S and P, where S represents a seat and each P represents a plant. So one run divider had already been installed on the left index 0, another to the right index of n-1, additional run dividers can be installed. So in here that is mentioned that we are allowed to install the additional run dividers that be more than once, and for each position between indices I-1 and I, we have to make at most one divider can be installed. Oh wait, at most means we can only install the one divider. So divide the corridor into the non-overlapping section, so where each section has exactly 2 seats. So that means whatever we want to divide the corridor into the section, each section exactly need to have 2 seats, no more, no less, with any number of plants. And there's a multiple ways to perform the division. So 2 ways are different. If there is a position where the run divider instead of the first way, but not in the second way, we have to return the number of ways to divide the corridor, since the answer may be very large. So we have to return it in the modulo. Okay, that is the first thing we could do. Let's call it mod, not mod, integer of LE 9 plus 7. Let's check my mod is correct or not. Wait, I totally forgot. Let me think. What is the do round? Okay. Before we solve this problem, maybe let's try to understand the. Oh, not the L. It should be the 1. Silly me. I think that is probably the wrong answer. Yeah, just trying to return the value first. So if we have to deep dive into the problem, normally we may have one line in here. So let's go with the iterative approach. Let's consider we have one index in here, and then let's do the brute force way. Since if we go from 0 index to here, so there is a 1C which is not valid, and go there, that is a 1 valid option. So that's why we count the value as maybe z is originally the 1. And then we move to the next step, which will be the here. So that's also the valid, since we have a 2C on the left and 2C on the right. So our result will become 2. If yes, move to the next step like this. Okay, that's a very tricky part there. So again, the result is 3, since there's a 2C on the left and 2C on the right. So last but not least, if we go further move from here to there, that is not valid anymore. The same for the next index 5, the same for the index 6. That is the reason why we are receiving the output of 3 in here. So, okay. That is very straightforward for the hard question, but it will be struggle when we really start working on the coding part. So let's go for the example 2. Let's consider like we have like this. Since there's only 2C, there's only one way. Yeah. Alright. Okay. We may have a question. What if we have a 2C, but why don't we not able to put the divider in here? Since if we put the divider in here, the section in here won't have any seat. So we only have one plant in here. So that is the reason why we don't count that as a one valid answer. And that is the reason why we only have a one corridor in here. The same for example 3, since there is only one seat, there is no way to divide the corridor. and then character of lunch. Okay, and then we have a valid solid option, right? The character is either S or seed or plants. So maybe I was thinking that is dynamic programming, if I am not wrong. Yes, exactly. And then what I could think of is maybe we convert the string into the character so that we could save the time when we try to index each character of the string. Let's use the same variable like character. That is the array of character. And then we need the one thing called count, which is a dot count. Yep. After that, let's try to work on create the inner function called default search. What I'm going to use is the index, and next is the seed, like how many seeds we have in the given recursive function. We just return the integer in here. And then we can count like if our index is exactly equal to the count. That means like index is 0, and then the count is also 0. No, we need to check like what if like we have count is so count is become the index 4 and then it become the less. We need to check like return the C is 2. If C is 2, we can return is a 1 valid option. And then next, if C is not 2, we just return the 0. Alright, and then we can start work on the accessing the character. Let's consider like let character equal to character of index, and then we will check like maybe if seed is already 2, that means we have another seed, and now we can accept animal seed. And then mean like not how does it begin? It should be the seeds. So if we have enough seeds, we have 2 options. First is we found the character is a seed again. If like that, we need to start a new session. Okay, I'm gonna need a new variable here, which is called reset. It's additionally 0. And then our call is like by calling the same DFS with the index moving to the next step, and then seed is still the 1. So that is our intuition for initially. If we find the plant in here, what I'm going to do is I'm going to use 2DFS by moving the index to the next step. One is a 0. Since we have enough C, and then we find a plant, we just need to move the index to next, and we will not start the new session. Plus, next possible is we will start the how to say another one. Like we have enough C, but we will pass the C as a 2. So returning the C as a 2 in here mean like we just want to check like we are using the correct approach or not in here. And then based on that result, we need to mop it. Yeah, we better mop it. Okay, I was thinking like, okay, we have a reset in here. And then if our reset is greater than or equal to the mods, that means like we cannot have a value more than the mods in here. If more than mod, I will just detect from the reset, which is mod. Alright, that's pretty much if we have seeds in here. How about the not enough seeds? So same option, they could cost like the previous before. We will sort the seed, and then if we sort the seed, that's pretty straightforward. We just move the index to the next, and then by adding the seed to the +1, since we saw the one seed. For the next step, if we see the plants, what we are going to do is we will still also move the index in the next step, and then the seed will remain the same. Yep, if everything is pretty much done, we just return the reset, and then here we'll be starting with the default search with the 0 seeds and 0 index. Let's try to run and see it's work or not. Alright, that should be the anonymous variable for the out variable in the Swift. Okay, let's try to submit its pretty work, or we should call the time limit AC, because since we're using the recursive and the possibility is 10 power 5 in here, that could cause exactly yeah. So if like that, maybe we can cache it by using the memoization. Okay, let's call like memoization, and then maybe create the array repeating of I need a nested array, like repeating of -1. Count is yeah, I can think of it as a count is a 3 because we have a seeds and plants. So if we have 3, so we are able to calculate like what is the seeds, what are the counts possibility in here, and then the count will be the n+1. So how are we going to memorize it? Maybe in here, let's consider like if memoization of index, which is our reindex, and then seed. So seeds can be 2 possibilities: 0 seed, so 1 seed, and 2 seed. That is the reason why I'm putting 3s in here. Seeds are not equal to the -1. That means like it's not saved in our cache yet. And then yeah, it's already in the cache. Then we can directly return our memoization with the index and seeds. Okay, next step is we need to cache our reset. Maybe in here, index and seeds. That will be the reset. Let's try to submit again. What did I do wrong in here? Oh, CDB shift the count. Yeah, that's very confusing since you saw the counts and you don't want to type the counts again, so I put the randomly n. Okay, let's try to submit and see it's work or not. Yes, that's pretty much solved the problem. I think the time complexity will be the O of n if I am not wrong. The same for the space complexity since we only use the one memoization array in here. Yep, that's all for it, and then see you in the next one. Bye.